Good day everyone, today we are going to explore the Charle's law. It is a fundamental principle in chemistry that describes the relationship between the temperature and volume of a gas at constant pressure. The Charle's law states that the volume of a gas is directly proportional to its absolute temperature when the pressure remains constant. This means if you increase the temperature, the volume will increase proportionally and vice versa. This relationship is represented by the formula V1 over T1 is equals to V2 over T2, where V is the volume and the T is the absolute temperature in Kelvin. Now, Charle's law, real-world application. Charle's law has many real-world applications. For instance, we have hot air balloon. It rises because heating the air inside increases its volume, making it less dense than the surrounding air. Weather balloons also rely on this principle. As they rise into colder air, their volume decreases. So for the other real-life applications of the Charle's law is we have car tires. Tire pressures increases on hot days because the air inside the tires expand as it heats up. Next one is we have basketballs and other inflated balls. In cold weather, balls may appear deflated because the air inside contracts with lower temperature. Next, we have lungs and breathing. As air is warmed entering the lungs, it expands, making breathing more efficient. Next is we have refrigerators and freezers. Gases are compressed and cooled, then allowed to expand and cool for the temperature and volume changes follow Charle's law during the parts of the cycle. Next is, lastly, we have the helium balloons. Helium balloons, if left in sun, helium balloons expand and might burst. Left in the cold, they shrink and look deflated. So those are the examples of real-life applications in Charle's law. And now, we are going to conduct an experiment or stimulation that clearly demonstrate a gas law, the Charle's law. So today, we're going to start our experiment.
The first step in any experiment is to prepare our personal protective tools or PPT. This helps keep us safe from any chemicals or materials we'll be working with.
For this experiment, we will need to use one balloon. It should be partially inflated,
Container with hot water, and a container with full of ice.
So the balloon will serve as our gas container, allowing us to clearly see any volume changes. Now let's begin by placing the balloon into the hot water. Notice how the balloon expands as the air inside heats up. The gas molecules gain kinetic energy, so they move more rapidly and spread further apart, increasing the volume of the balloon. This is a direct demonstration of Charle's law. Now let's see what happens when we place the same balloon into ice water. As the gas cools, the kinetic energy of the molecule decreases. They move more slowly and come closer together, resulting in a reduction in volume. Again, this behavior aligns precisely with Charle's law. So in conclusion, these experiments illustrate Charle's law in a simple, observable way. When the temperature of a gas increases, its volume increases. When the temperature decreases, its volume also decreases as long as the temperature remains constant. This principle is not only crucial in scientific research but also has real-life application from hot air balloon to internal combustion engines. Now, understanding gas behavior under temperature change is essential in both physics and chemistry. And that's all, everyone. Thank you.